In JavaScript, a promise is an object that represents the eventual completion or failure of an asynchronous operation, along with its resulting value. Promises provide a cleaner and more manageable alternative to callbacks, helping developers avoid the infamous callback hell. Promises can exist in one of three states: pending, which is the initial state; fulfilled, indicating the operation completed successfully; and rejected, meaning the operation failed. Once a promise is settled, either fulfilled or rejected, it becomes immutable and cannot change states again. The basic syntax for creating a promise involves using the new promise constructor, which takes a function with two parameters: resolve and reject. The resolve function is used to mark the promise as fulfilled and return a value, while the reject function marks it as rejected with an error. For example, you can create a promise that resolves after a timeout by using setTimeout to call resolve with a success message. One of the key features of promises is the ability to chain operations using a then method. The then method takes two arguments, a success handler and an optional failure handler. Each then call returns a new promise, enabling developers to chain multiple asynchronous operations together. For instance, you can fetch data, process it, and then display it, all in a clean, readable chain. To handle errors, the catch method is used. This method is essentially shorthand for then null error handler, and ensures that errors are caught and managed properly, avoiding unhandled rejections. Another useful method is finally, which runs regardless of whether the promise is fulfilled or rejected. This is particularly helpful for cleanup tasks, such as hiding a loading spinner after an operation completes. Additionally, when returning a value or a new promise inside a then block, the next then in the chain will wait for the returned promise to resolve before proceeding. JavaScript also provides several static methods for working with promises. Promise resolve creates a promise that is immediately resolved with a given value. Promise reject creates a promise that is immediately rejected with a specified reason. Finally, Promise.all takes an array of promises and resolves when all of them succeed, or rejects if any one of them fails. These static methods are powerful tools for managing multiple asynchronous operations efficiently. By understanding and leveraging promises, developers can write cleaner, more maintainable asynchronous code in JavaScript. Promises are a fundamental feature in JavaScript for managing asynchronous operations. They provide a cleaner and more structured approach compared to the traditional callback pattern. For example, Promise.all is a method that waits for all promises in an array to resolve. However, if any one promise fails, the entire Promise.all call will reject. On the other hand, Promise.race resolves or rejects as soon as any one promise in the iterable settles, making it useful for scenarios where you need the fastest result. Promise.all.Settled, introduced in ES 2020, waits for all promises to settle, whether they are fulfilled or rejected, and returns an array of objects detailing their statuses and results. Meanwhile, Promise.any resolves as soon as one promise fulfills. But if all promises reject, it throws an aggregate error containing all the rejection reasons. Promises are widely used because they enable a cleaner asynchronous flow, better error propagation, and the ability to compose multiple async operations. They are standardized in ES6 and are well supported across modern JavaScript environments. However, there are common mistakes to watch out for. For instance, forgetting to return a promise in a then chain can break the chaining mechanism. And mixing callbacks with promises can lead to confusing and hard to maintain code. It's best to stick to one style per flow. Building on promises. Async, await was introduced to make asynchronous code more readable and easier to manage. Async, await is essentially syntactic sugar over promises. For example, using async, await, you can write an asynchronous function to fetch data from an API in a way that looks synchronous. By using try-catch blocks, you can also handle errors more effectively. This combination of promises and async, await has become the standard for managing asynchronous operations in modern JavaScript development.